Schrödinger equation is solved for hydrogen atom, the solution gives the possible energy level the electron can occupy and the corresponding wave functions, which is denoted by the psi of the electron associated with each energy level. So generally question will come that what is the wave function? The wave function is a mathematical function whose value depends upon the coordinates of the electron in the atom and does not carry any physical meaning. That means this wave function, this value depends the coordinates of an electron. Coordinates of electrons means if we know the graph, you know that here you have the x, y and z axis. It is like that. And this wave function value does not carry any physical meaning. So this quantized energy states, which is electron associated with it, and corresponding wave functions, which are characterized by a set of 3 quantum numbers. We have to remember these 3 quantum numbers. The principal quantum number denoted by the small letter n, azimuthal quantum number denoted by small letter l, and magnetic quantum number which is denoted by the small letter m subscript small letter l. And this set of 3 quantum numbers arise as a natural consequence in the solution of the Schrödinger equation. What I already told that in this point about the Schrödinger equation, we'll understand this much. When an electron is in any energy state, so it will definitely have the wave function. So then the wave function corresponding to that energy state contains all information about the electron. That means an electron, what is its energy state, it definitely have one wave function, and this wave function will describe the all information about that particular electron. Such wave functions of hydrogen or hydrogen-like species. What is this? Hydrogen means we know that one electron system. Hydrogen has one electron. So if you consider that helium in its singly positive charge state, so helium has 2 electrons. So if helium is its singly charged positive state, then it also has 1 electrons. So He plus, this is called the hydrogen-like species. Like that, other species or some species also there. And then such wave functions are called atomic orbitals. Such wave functions pertaining to 1 electron species are called 1 electron systems. The probability of finding an electron at a point within an atom is proportional to the psi square at that point. That means probability will proportional to the psi square value. Psi means wave function. So square of the psi at that point, it will show, it will count the probability of that particular electron at that particular point. The quantum mechanical results of the hydrogen atom successfully predict all aspects of the hydrogen atom spectrum, including some phenomena that could not be explained by the Bohr model. That means this quantum mechanical model successfully describe the one electron system like hydrogen atom, which cannot be explained by the Bohr model. So, in the case of application of the Schrödinger equation to the multi-electron atoms, it faces some difficulty to explain that system. That means multi-electron systems. What is this? Schrödinger equation cannot be solved exactly for a multi-electron atom. This difficulty then can be overcome by using approximate methods. Such calculation with the aid of modern computers show that orbitals in atoms other than hydrogen do not differ in any radical way from the hydrogen orbitals, as I discussed now. But the principal difference lies in the consequence of the increased nuclear charge. That means we know that for the multi-electron, the number of electrons will increase, and definitely its nuclear charge, that means proton number also will increase. And that's why for the multi-electron atoms, it differs from the one electron system like hydrogen. So because of this, all the orbitals are somewhat contracted. That means because of the increased nuclear charge, the outer orbital, what is there, it will be little bit contracted towards the nucleus. And that is the reason why the Schrödinger equation cannot be solved for the multi-electron atoms. Unlike orbitals of hydrogen or hydrogen-like species, whose energies depend only on the one quantum number n, because we know that hydrogen or hydrogen-like species only has one electron, so it depends only on the principal quantum number n, and the energies of the orbital for the multi-electron atoms depend on the quantum numbers both n and l. That means principal quantum number n and azimuthal quantum number l. And that is the reason why the difference is happening for the singly electron system to multi-electron system.